Hi guys, this is going to be the ninth question on your homework, and let's see what it is talking about. So you have a forklift, and then it has a mass of 300 kg right there, and then what happens is this guy is accelerating downward with 1.5 meters per second squared, and then they will also tell that in the next part it is also accelerating, so that's your AY and that's your acceleration AX, and then that's going to move to the right with 2 meters per second squared. So your T0 conditions are 2 equals 0 conditions are x equals 0 and y equals 2 meters. So this guy is 2 meters above the ground at the beginning. So that's basically the picture, that's what's happening. And then in the first part they're asking for determine the upward force exerted by the horizontal platform. So basically they're asking for the normal force of this object. So it's always important that we start with a free body diagram, of course. So if you would like to draw the free body diagram of this object, it is going to have mg or fg, whatever you would like to call it, and then you have a normal force, and that's what they're asking for. And if you read through, you will also see that this block is not able to move backward because of the friction. Normally, if you think about inertia, when it moves, it should actually go backward because of inertia, but it's not going because of the friction. So since that guy would like to move backward and it's not able to, then that means my friction is going to be acting to the right. So that's my free body diagram of the object. And then I will also go for x and y. So total force on the x equals mass AX, total force on the y equals XM AY. Alright, so since they're asking for the normal force, so I need to deal with the y components. I have only two forces acting on that axis. So my upward force is Fn, and my downward force is mg, so that's negative, and that's equal to mass times acceleration on the y-axis. So, and for part A, simply you will just use this equation, Fn minus mg equals may, and you will solve this for Fn, and Fn equals may plus mg, basically. So what's my mass? It is 300 kg. And what's my acceleration on the y-axis? Alright, so it's important that we recognize my acceleration on the y-axis is not 0 this time, because this object is moving downward. So we need to consider that acceleration, and that acceleration is downward, so you should consider that as negative 1.5. Plus, my mass over here is what? Again, 300 times gravity. So my gravity, alright, that might be a mistake that you can make. We are going to take this as 10. Why? Because we consider that negative, that g, as being negative over here already. So if you put negative 10 right there, then you basically put that negative twice. Alright, so here we just put acceleration as positive because we don't know, or we didn't consider that the acceleration is downward, so we didn't put a negative over here, but we included that negative right there. But in the free body diagram for the mg, we already decided that it's going downward, so it's already negative. So that is already given right here, so you don't need to do that twice. So that is important. That is going to be positive 10. This is going to be negative 1.5. And when you do the multiplications, then you will find your Fn as 2,550 newtons. Alright, so that's your normal force acting on the object. In part B, they're asking for the friction force. So, friction force can be found two ways actually. Friction Fn times mu. But here, if you would like to go through this equation, you do not know your mu. Yes, you know your Fn, but you don't know your mu. So that is not going to be helpful for you. But what else do we have? On the x-axis, friction is the only force acting on the object. So all of the forces means friction force only, because there's only one force. And that is equal to mass times acceleration on the x-axis. So then for this guy, then I will just say Ff equals mass times acceleration on the x-axis. And my mass is 300 kilograms, and my acceleration on the x-axis is 2 meters per second squared. So my friction will become 600 newtons. And in part C, they're asking for what's the minimum coefficient of friction that you might have for not the slide. So in this case, it's simply F friction. So now we know the friction, we know the Fn, now we can find mu. So Fn times mu, and my mu is equal to friction force divided by Fn. And in this case, my friction force is 600, and my Fn is 2,550, and my mu will become 0.24. And for part D, that's a little bit different. So for part D, they're asking for motion on the y-axis in terms of motion on the x-axis. So when we start motion, my x equals 0 and my y equals 2 meters. So what is the relationship in between those two? Well, since x and y components, motion in the x-axis and motion in the y-axis, they are independent from one another, but there's only one thing that is combining those two. That's time. So what we will do is basically we are going to use the equation of delta x equals v initial t plus 1/2 a t squared. And we'll also do the same thing for delta y, and then that will be the same thing, 1/2 a t squared. The only thing that will be the acceleration on the x-axis, and then that will be the acceleration on the y-axis. So my initial condition for both cases is velocity is 0 for both, because my object starts from 0. So that is going to make things a lot easier for me. So my delta x is basically x final minus x initial. So x final is any x, like any position that we're talking about, and my initial x is 0. So this part is basically x final minus x initial. So my x final is, since they're asking for a function, we don't know any time, like any position. So you just define this as just x, meaning that it's any distance, minus initial location, which is 0. So that will become x. So my delta x is simply x, which means any position x. And how can you find your any position x? It is basically 1/2 a t squared. And what's my acceleration on the on the x-axis? That's 2 times t squared. So my x as a function of time is simply x, like t squared. And what do I have on the y-axis? So my delta y will be a little bit different. So I need to do the same thing for the delta y. So that should be y final minus y initial. And what's my y final? Again, just like this one, any position x. So that will be any position y on the y-axis. But my initial condition for that is not 0. My initial location for the distance on the y is 2. So my delta y is going to be y minus 2. So my initial t is 0, and then that will become 1/2 ay. What's my acceleration on the y-axis? It is 1.5 and then t squared. So now what do we have? You have two functions. This is function of position on the x-axis, and then this is the function of y on the vertical axis. So that's the horizontal, that's the vertical. And then they are asking the relationship in between the location, the position in between the horizontal and the vertical axes. So what should we do? We have t squared on both, and this t squared equals x. So all you need to do is just replace this t squared with x. Then your y as a function of x will become, so 1.5 divided by 2 is 0.75, and then that 2 will go to the other side as positive 2. 1.5 divided by 2 is basically 0.75. And then for t squared, I have my x. So this is my function of y in terms of x. So that is going to be the answer for part D. And last part is simply asking for the graph. Well, it is going to be actually pretty simple in terms of drawing the graph. Alright, let me just fit that guy over here. So this is your y, meters, and then this is your time. So your initial position is basically what? 2 meters. So you're going to start with 2 meters. And what do? You are going down with 1.5 meters per second square every second. So then you will just have a straight line, and then that will go to 0. And what is the time that I'm going to reach to 0 on the y-axis? So we can simply use this equation to figure that out. So y minus 2 equals 1/2 1.5 t squared. That's my equation. So I would like my y to be 0. So how is this possible? And I think we missed this part over here. So you need to have negative right here because your acceleration is negative. So this whole thing will going to have this negative over here. So now this is going to be negative. So this is going to be 0. 0 minus 2 is negative 2. And then negative 1/2 times 1.5, which is negative 0.75 times t squared, and then if you follow this, then your t squared is going to be equal to 2 divided by 0.75. And if you do the math over here, then you will find your t as 2.3 or something like that. So that guy is going to be like 2.3 seconds. And that is it for this 9th question on your homework.